You learned simulation. Maybe you used COMSOL, ANSYS, or Abacus, but no one really tells you what comes next. Can you actually build a career from it? Could it actually make you money? In this video, I'll show you 4 career paths you can take with simulation, and the approximate salary range for each one. So let's get started. The first path is a simulation engineer, which is an engineer who uses computational models to study how physical systems behave. They replace expensive physical experiments with virtual experiments inside a computer. So this is mainly an industrial role. You can be an FEA specialist, that is, you can specialize in the finite element model or finite element analysis. This role also greatly overlaps with the structural analysis, that is focusing on stresses, deformation, fatigue studies, and structural mechanics. You can also be a CFD engineer or computational fluid dynamics, specializing in fluid studies. This is one of the popular paths and specialties in simulation. You can also be an electromagnetic simulation engineer, a thermal simulation engineer, a multiphysics engineer. So basically you specialize in a specific physical phenomena and you work for a company to build a specific product. You will also hear about a CAI engineer. A CAI stands for computer-aided engineering. In many companies, CAI engineer and simulation engineer mean almost the same thing. The difference is mostly context. The typical salary for this kind of jobs shown here in the screen, this is only an estimation. This kind of salary highly varies between countries, the entry level, companies themselves, so you have to go to a specific website like LinkedIn or Indeed and look for this specific role yourself. The main point of this video is just to show you what are the career paths available so you can search for them individually. The second path you can take is a research scientist. A research scientist in simulation uses computational models to discover new knowledge, not just design products. While simulation engineers usually optimize existing systems, research scientists often simulate things that are not fully understood yet. This work usually takes place in universities, research institutions, advanced R&D department, and companies. Examples include simulating like a blood flow in arteries, or simulating the climate change in Earth, or discovering a new numerical method like improving upon the existing methods, or a new method like the meshless methods, paradynamics, or making faster solvers for BDE or AI-assisted simulation, for example. For the salary, while research scientists can earn anywhere from 19,000 to over 200, depending on the field and industry. In academia, salaries grow slowly, but in industrial research, especially overlapping with AI, they can go extremely fast. By the way, if you're interested in this content, consider subscribing to support the channel. I'm growing this channel to spread the idea of simulation beyond what people usually see, not just a software, but a way to understand and shape reality. The third path you can take is a simulation software developer. This is one of the most elite paths in simulation, and instead of using tools like COMSOL or ANSYS, you become the person who builds them. A simulation software developer creates the core technology behind simulation, like the physical solvers, finite element, CFD, electromagnetics, numerical algorithms, meshing systems, optimization tools, or HPC systems, or high-performance computing. This path is more technical than all the others. You need to be skilled with programming, mathematics, and the main physics in question. You can expect that the salary is higher than the previous fields because this is a more specialized work. The fourth path you can take is being a consultant or freelancer. And here's where it gets really powerful. You don't need a company, you can work independently. You can look for projects online and get paid for each. Moreover, some engineers become certified consultants. For example, officially listed on the platform on COMSOL, there are multiple consultants for each country. The salary for this one highly varies because it depends on the country and your work. So at the end of the video, I want to thank you for watching and also want to remind you that simulation isn't just a tool, it's a gateway to research, industry, and even your own business. So tell me in the comments, which path will you take?